Hello, this is Eric from Bay Area Hang Gliding, reading another ground school article. This is a more advanced article, and of course my phone's going to ring, so I should have turned it off. Alright, this is an article written by Gadd. Is called Thermals. This is part 1, Collectors, Wicks, and Triggers. The crux of cross-country flying often lies in correctly answering the question, where is the next thermal? If you can answer that question correctly even 90% of the time, then life would be very, very good. I think it's key for every XC pilot to develop his or her own system for understanding thermals, then continuously refine it. Only in this way will the pilot actually learn something with each success or failure. I often hear students in clinics I teach say, I sort of knew that, but this simplifies things a lot. That's the goal, to have a simple, clear system that you can refine each season to produce better results. I broadly split my thermal prediction model into 2 parts, ground-based thermal prediction ideas and sky-based thermal clues, or cues. This article is my attempt to explain to myself and anyone who finds it interesting how thermals form on the ground and how to find them efficiently. Part 2 will deal with the sky. Part 3 with staying flying thermals. Collectors. They call potential thermal generating areas collectors because they collect the sun's energy and release it as warm air or thermals, a process any successful XC pilot should be very interested in. I think the air in collectors tends to warm up as the sun heats the ground, first releasing relatively slowly and steadily. Early morning mountain thermals are the best example of this, followed later in the day by more violent sets, or cycles, in much the same way waves hit a beach. Imagine small waves coming in continually, then a big set ripping through, followed by small waves again. If you find a good collector, you can often maintain in a zero over it and wait for a good set to go through. If you're low, this may be your only chance. Collectors are all about the sun. If there's no sun, then there's probably not much air leaving the ground. Cold fronts and other very unstable air masses are exceptions. When looking at any potential thermal collector, I first ask, how long and at what angle has the sun been shining on the collector? A perfect collector would be at right angles to the sun for hours. I first learned this lesson flying in the 96 US Nationals when all the top pilots flew to the sunny but lee side of the ridge, and I went to the windward side where the sun was just starting to hit. I sunk out, they didn't. At the time, I thought this experience was bad luck. Luck had nothing to do with it. The slope simply hadn't been in the sun long enough. The next factor that determines how much the air heats up is the surface the sun is striking. For an excellent analysis of surface thermal theory, read Reichmann's Cross-Country Soaring. Basically, dry surfaces with a lot of trapped or sheltered air will produce the best thermals. Late season cereal, wheat, oats, etc. crops are dry, hold a lot of still air, and consequently release some of the best thermals. Dry shrubbery also works well. Rocky terrain with a lot of dead airspace between the rocks works well, but takes longer to heat up. Moist ground cover absorbs the sun energy and uses it to evaporate water, a cooling process that kills thermals. Wind tends to destroy thermals by continually mixing the air in potential collectors, preventing it from either reaching the temperature at which it will leave the ground, or turning what could have been a decent thermal into a ragged mess, especially close to the ground. A large line of hedges or trees around a very dry but bushy field will often hold a nice still pocket of air. You can experience thermals on the ground by just walking around. Sunny, dry spots protected from the wind will be warmer. As odd as it may sound, I've learned a lot by simply walking in the mountains and feeling the cool air in the pines, contrasted with the warm air on avalanche slopes or other treeless areas. The more protected and sunny a collection area is, the warmer it will be, and the better chance you as a pilot will have of going up. This means that the best thermals are often found in sunny lee areas. This is no problem if you're high and fly above them, but you have to make your own decisions about how much rotor you want to play with when you're lower. This isn't an article about safety. Many pilots believe that Black pavement, such as that found in big parking lots or roads, will be a good thermal source. Although pavement is black and absorbs tremendous amounts of energy, it often doesn't work very well because there's nothing to hold the air into place. If you watch birds soaring above a parking lot or freeway, they will almost always be turning very small circles and not gaining much altitude. The thermals are frequent, sort of like grease popping off a skillet, but frequently unusable. Interestingly, a parking lot filled with cars generally works better than one without cars because the cars hold dead air nicely. A road can be a good wick, but more on that below. The aspect angle of the terrain is critical. For example, dried plowed fields almost always work better than dry flat fields. I think this is because the sides of the furrows tend to face into the sun like little solar collectors, while the actual furrows protect the warm pockets of air from the wind and allow them to develop. If you're mountain flying, then look for the slopes that have been at right angles to the sun the longest. Lee slopes often work better than windward slopes because of the air in the lee is protected, but a windy slope in the sun will beat a shaded slope in the lee every time. Really massive southwest facing slopes in the mountains may offer continual strong thermals from midday through early evening, but east and due west facing slopes will only work in the morning and evening respectively. The anti-collector is, of course, a lake. Cool, reflective, moist, often windy, you will almost never find a thermal that comes from a lake. That is not to say you won't find thermals over lakes, but they aren't coming from the lake itself very often. One exception may be very late in the day when the relatively warm water releases heat, but I have very seldom seen this happen in a strong enough manner to produce usable thermals. Long glides over lakes in the evening are often quite buoyant, but don't count on magic air too often or you may be swimming. Passive triggers and wicks. I believe thermals have some form of surface tension and tend to track along the ground before releasing, sort of like oil up a wick. I call the point at which the thermal leaves the wick a passive trigger. The most passive trigger is the top of a sharp peak. There will often be a cloud over it from 9 in the morning until sunset, even as the sun rotates from east to west. First the east-facing slopes warm, they wick up the hill and release, then the southeast-facing slopes, then the south slopes, followed by the west-facing slopes at the end of the day. However, the thermal comes up the wick to the same passive trigger. Think about the house thermals at your local site. What's really happening with each one as the sun rotates? If you're high, then you can fly straight to the wicking top of the peak, but if you're low, you need to fly to the sunny side of the peak and then climb out. Ridges often work the same way, with convergences happening if both sides of the ridge release at the same time. When mountain flying, I look for points where I think bubbles might break their tension and lift off. Ridges above protected slopes in the sun, and places where a ridge forms a mini summit for thermals to break off at, like water running down your arm and falling off at the elbow. Seems to work best. 2 or more ridges coming together are better than one. Each ridge increases the chance that you've picked up the right wick. If you're bored, take a spoon and stick it to a glass pot of boiling water sometime. It nicely illustrates how all of this works. Passive triggers can be very, very small when flatland flying. For example, a road on the downwind edge of a large dry plowed field will often add a small ditch between the road and the field. This is a passive trigger for sure. Just like the edge of a dry field against a more vegetated field may be enough to lift the air off. I almost invariably find my best thermals in downwind corners of large dry fields, places with maybe a hedge or even a simply grass instead of plowed dirt. A group of houses in the middle of a barren section, or even a lone oil well breaking the monotony of flat ground will often wick thermals skyward. Some people believe strongly in power lines as passive triggers, but I think the thermals found above power lines generally have more to do with the terrain. The exception is that really big high-tension towers be wicking thermals skyward, but this is suspect. Thermaling over power lines does impose a bonus hazard as well. Large rocks are often good triggers, or good wicks and passive triggers, as they tend to pierce the surface tension and also release bullet-style thermals, allowing larger pockets of air to also leave the ground. Finally, Contrast in surface temperature may affect lapse rates and also act as triggers. I often find thermals at the junction of two disparate surface types. Miles of dry fields leading up to a large lake will often have a reliable thermal at the boundary between the two. If the wind is coming from the fields, this thermal will slope out over the lake. However, wet fields or lakes will often shut down all activity in their immediate area, especially on the downwind side. These surface temperature differences can be quite small, but thousands of examples have taught me that they matter. Active triggers. Active triggers are triggers that move. For example, a tractor harvesting dry wheat field will almost invariably be a thermal source. Cars driving back and forth on a road next to a big dry field will also act as triggers. Any type of motion, be it from people, farm equipment, cars, or even other glider pilots landing, will often cause a collector to release. How many times have you landed in a likely field only to watch someone climb out above you? I'm starting to believe that cloud shadows will also often act as active triggers. I have flown enough sites now where the forward edge of a cloud shadow will produce dust devils as the shadow advances across the ground, something like a mini cold front lifting the warm air up. It's a theory, but it does seem to work some of the time. I definitely agree with that one. How to apply all this? On any given day, thermals reach a certain height before stopping, a distance between the ground and cloud base or the top of the usable climbs. I call anything below half this distance low and anything above it high. For example, if cloud base is at 6,000 feet above ground level, then I think I'm high above 3,000 above ground level and low below this point. This article deals with making decisions while in the low zone. If you're low, head for collectors that are in the sun and have been for a long time. Be very careful flying into cloud shadows. If you're low, it's very rare to climb up out of a cloud shadow. Connect the collectors with the potential wicks and triggers. Sunny meadows below a sunny ridge and a light lee with puffy clouds. Directly above are perfect. If you're on the shady side of a ridge, then you're in the wrong place and need to find some sun in a hurry. A big brown field with a small knoll on the downwind edge would be good, or a big dry grassy field that meets a busy interstate. I try to fly over as many potential collector/wick/trigger combinations as possible. Even if I get a consistent 0 on my varia while low, I'll stop and circle until a thermal set comes through. Of course, if you see a hot going up like mad or a big dust devil spinning off the back of a tractor, well, then things get even simpler. I won't mess with weak thermals if I just hopped out a climb and I'm starting a glide. There's no point as they will probably end soon anyhow. I will stop for anything solid once I get into my low zone. I'll add a quick rule of mine. I like to climb 1,000 feet before I try and adjust a thermal when I'm in the low zone. It's important to understand that the lift and sink generally balance each other out, especially in relatively small areas. If your climb rate is 1,000 feet per minute, expect at least 1,000 feet per minute sinking air when leaving a thermal. If the thermals are large, expect big areas of sink. If you're in an area of violent sink, then somewhere close by is probably a violent thermal. You should ask, where is the collector? You should ask, where's the wick? Where's the trigger? Attack. Collectors also tend to draw air into them as they release. You will often notice an increase in your ground speed as you near a thermal. Your glider will also often pitch ahead by a few degrees as the air accelerates toward the thermal and your heavy body lags. Older gliders will generally fall slightly behind you as they hit a strong thermal, but be very pressurized if you can feel this in the brakes. Wind gusts or turbulence may cause a glider to fall back behind you as well, but the pressure will not be as high in the glider. This is a great way to tell if you're entering a thermal or if you just found a wind gust. If the glider is pressurized harder, then you found a thermal. No pressure, no thermal. Newer, 1999 and on. Or high-performance gliders usually surge forward into a thermal, no matter how strong it is, but the feeling of increasing brake/glider pressure is the same. Finally, remember that the wind slopes thermals. If you're relatively low and coming into a collector, then it won't matter much, but the higher you are, the more downwind of the source you need to be to intercept the column. The system above may be largely wrong, but it's the best one I've developed yet. Each year it seems to get a bit better, and each year I look back and think, oops, was I ever wrong about that? I try to honestly look at each flight and think, what worked, what didn't? Why did I sink out and someone else succeed? Good pilots create their own thermal luck remarkably consistently. So good luck depends on developing your own system, and that's the one that matters. Okay, the camera's over there. This is filmed on an iPad. Sorry I started early for those of you that might have been waiting. I see no one watching. So I'm going to go ahead and sign off now. Bye.